In this video, I'm going to introduce radioactivity. First is some terminology, the difference between radiation and radioactivity. When we say radioactivity, we're talking about the property or capacity of radioactive materials to emit radiation. So if we could use an analogy, if the flashlight was the radioactive material, the light emitted from the flashlight would be the radiation. Now there's different kinds of radiation. Radiation is all around us. We have visible light coming from the sun or coming from the lights. This is all radiation, electromagnetic radiation. UV light is radiation. Radio waves. Microwaves are some other examples. So these are all types of radiation. And we can divide radiation into two types. And you can think of it kind of like the dangerous type and the not so dangerous type. The dangerous type is called ionizing. And that's because the radiation has a strong enough energy that it can cause the atoms in your body to become ions. And that can cause mutations, which can lead to cancer. Non-ionizing radiation, like radio waves, are not harmful. This diagram shows the electromagnetic spectrum, and you'll see gamma rays on the right, gamma rays being the highest energy on the spectrum, and radio waves being the lowest energy. The energy of electromagnetic radiation is related to its frequency. And so gamma rays have the highest frequency. You'll also see here that this part of the diagram is meant to represent the wavelength. So radio waves have a very long wavelength. In fact, this is 10 to the power of 3, so 1,000 meters. A very long wavelength. Gamma rays have a wavelength of 10 to the power of negative 12 meters. So when we're talking about wavelength, we're talking about the distance from the crest of one wave to the crest of another. That would be one wavelength. Now you'll see that the wavelength decreases as we move to the right, but the frequency increases as we move to the right. So using this the space down here, what happens to the wavelength as the frequency increases? The wavelength would decrease. X-rays and gamma rays are examples of ionizing radiation. That's the harmful kind, and that's why you wear a lead apron or a lead vest when you go to the doctor or dentist. But why are some isotopes radioactive and others aren't? What is it about those atoms that makes them radioactive? Well, let's review what we know about atomic structure. In the previous video, we've looked at Rutherford's famous gold foil experiment. Which told us a lot about the structure of an atom. Told us that atoms are mostly empty space. Told us that the mass of an atom is concentrated in the nucleus. And we've also learned that the nucleus has a positive charge. That's where the protons and neutrons are. And it's this interaction between the protons and the neutrons that causes some isotopes to be radioactive. We'll look at this in more detail in the next video.